Okay, so we're going to have a look at how you can find outliers on a piece of data that you've got. So you might have drawn, for example, a scatter graph and thought to yourself, oh, this looks like it might be an outlier. But we can't just assume that it is. We actually have to check that something's an outlier. So it's quite nice to do this check at the start if it's relevant to your topic. So as an example, I've put a data set here. I've just made this up, and this is the height of plants. I've got 8 pieces of data there. So I can see I've obviously checked like 8 pieces of plants or whatever it might be. And the formula to work out the interquartile range is to work out whether something's an outlier is that it's 1.5 times the interquartile range. And then we take that number and we either add it onto the upper quartile, or we do the lower quartile and we subtract it from that. And that will give us the kind of boundaries of what the data should lie in. And if it's outside of that, then it's considered an outlier. So the first thing we're going to need to do is work out what is the interquartile range. So to do that, I've typed it into my GDC and I've got the list of all my data. And then I'm going to go to Menu, Statistics, Stats Calculations, and then One Variable Statistics. And we click OK. And it's asking me where is the data, so I've called that one height. The frequency is 1, that should stay like that because each entry has a frequency of 1, it happens once only. And then we click OK. So there's all sorts of information in this list. So if I wanted it, then I can find out that the mean is 6.05, and I can see that the standard deviation is 2.05 if I rounded it to 3 significant figures. Don't just include those anyway. Don't kind of think, well, I've got them, so it will give me extra marks. They'll only give you more marks if it's relevant to the work that you're doing. So don't just include things unless there's a reason for it, okay? There's a check there, so n is 8. That tells us there's 8 pieces of data entered into my table. And then this section gives me the minimum, the lower quartile, the median, the upper quartile, and the maximum. So that would give me everything I need to be able to draw a box plot. And if you're wanting to then draw a box plot, you can go online, and there's lots and lots of sites where you can enter those 5 pieces of data in, and it will draw the box plot for you. And it'll even compare kind of 2 different ones next to each other and things like that as well. But the ones that I'm interested in are the lower quartile, which is 4.3, and the upper quartile, which is 7.7. So if I subtract those 2, then that's going to give me my my interquartile range, and the interquartile range is 3.4. So I've now got the interquartile range which I need, so I can put that back into my formula, back into this part here, to work out what is my kind of regions for the outlier. So I'm doing 1.5 times my interquartile range, which was 3.4, and that's going to then be added on to the lower quartile and the upper quartile. So that gives me 5.1, and then I'm taking the lower quartile and I'm subtracting that 5.1 from it. So lower quartile minus 5.1, and that's going to give me 4.3 minus 5.1, which is a negative. So I don't even need to work that one out. It's not going to be any values of that I've got. I can also take the 5.1 and I add it onto the upper quartile. So that's going to give me 5.1 added to 7.7, and that gives me 12.8. So I can now check my data to see if there's anything that's bigger than 12.8. And if there is, then that would be considered an outlier. But there isn't anything bigger, so I have no outliers. So what you're doing here is you're essentially having your box plot and your worst drawing ever. Okay. And you're working out what your interquartile range is, which is this section here. And once you know that, you're going to times it by 1.5. So half of this distance is going to be increased again. Okay, so we're finding out like the extra half and then we're adding it on. So it might now be this big. And then we're saying, are there any extra pieces of data that fall outside of this region? And we're doing the same on the other side, so we're subtracting it. And if there's any extra pieces of data, then we just mark them on with crosses because they're outliers, so they're outside of the box plot. So we ignore them, and then the new minimum value starts here. Or we ignore the upper, and then the new maximum value is there. Okay, so that's how we're doing this, but it's using this formula each time. Okay, and that will help you to identify if it's an outlier or not. If it is, there's no right or wrong thing to do so long as you explain what you're going to do. So if you found that it's an outlier in both variables that you're looking at, then perhaps it's better to get rid of it. But if you argue the reason to keep it, then that's fine as well. If you're finding that it's an outlier in one of the variables but not both, then perhaps you want to keep it or get rid of it. It's entirely up to you, but you just need to justify why you've chosen to do whatever you've chosen.